Okay, let's look at another example of hypothesis testing in statistics. It says a medical investigation claims that the average number of infections per week at a hospital in southwestern Pennsylvania is 16.3. A random sample of 10 weeks had a mean number of 17.7 infections. The sample standard deviation is 1.8. Is there enough evidence to reject the investigator's claim at alpha of 0.05? Assume the variable is normally distributed. Okay, so several things we know from this. We know that the mean of the population, mu, is equal to 16.3. We know the sample mean is equal to 17.7. We know our sample size is 10, and that's going to be really important in a minute. And we know our sample standard deviation is 1.8. Oops. It is not wanting to do a decimal. Let's try this way. We'll trick it. Okay, so we know all this information. We are doing a hypothesis test for our means, okay? The key is our sample size. Our sample size is less than 30. And remember, when the sample size is less than 30, we're going to be using the t-distribution. So we'll pull that chart up in just a second. Let's start with step 1. Step 1, h sub 0, mu equals 16.3. H sub 1. Okay, let's go back and check. Nothing in here says greater than. Nothing in here says less than. There's not the word differs. This one is one of the rare ones where they are claiming the equal to, because is means equal to. So I can write claim beside the equal to. And my alternative, remember when it's an equal to, it's always an equal to and a not equal to. So this is one of the ones where they claim that their population is the same. They're claiming it's equal. So we do an equal and not equal to. Now remember, that would be a two-tailed test. So that's going to change things a little bit as well. So we're going to have a two-tailed test this time. Anytime it is equal to and not equal to, it is two-tailed. If it is less than, it is left-tailed. If it is greater than, it is right-tailed. This one is two-tailed. Our alpha was 0.05, so let's talk about that for a minute. Now, when we did the z-distribution, and it was two-tailed, we had to split the alpha in half. But I want to refresh your memory on the t-distribution. Let's do this one more thing, and then we'll look at the table. If sample size is 10, we're going to need degrees of freedom. And remember, degrees of freedom is n minus 1. Okay, so that is going to be, whoops, I'm running out of room there. My degrees of freedom is going to be 9. Let me erase that and fix that real quick. Degrees of freedom would be 10 minus 1, and that would be 9. Okay, now let's look at the chart. When I pop up our chart here, if I can find it. There we go. When I pop up our chart, this is the z distribution. N is greater than or equal to 30. That's the negative side, the positive side. And remember, this chart reads from the left. We talked about that in the last video. When your sample size is less than 30, you have to use table F, the t distribution. So anytime sample size is less than 30, you're on the t. Another hint is when you get down here on this particular chart, it starts skipping numbers, because if you're down here, you really shouldn't be on this chart. Okay? This one is a little bit different than the Z. See how this one has one-tailed, two-tailed for hypothesis testing? The Z distribution doesn't have a two-tailed, so you have to split your alpha. On this one, it has a two-tailed, so I do not have to split where it said alpha equals 0.05. I don't have to split that, okay? I just have to look at two-tailed alpha 0.05. And my degrees of freedom was 9. So I am going to go down here to 2.62. So the number I'm using for two-tailed alpha 0.05, degrees of freedom 9, is 2.262. So I'm going to go back and put that on my chart. And then I want to show you something else about this chart. I like that it has two tails, but one thing that students have trouble with on this chart is remembering that it doesn't give you a negative. If you have a left-tailed test, you have to remember to make that value negative. So when it's left-tailed, you make it negative. Right-tailed, you make it positive. The chart doesn't do that for you like the z-table does. So for our step 2 down here, we're going to write critical value equals plus or minus 2.262. Okay, now we're ready for our step 3. Fortunately, the formula is very similar to the last one. We'll look it up real quick. Formula for your test value, your t value. Let's pull that up on our formula sheet again. If you go to Chapter 8 Formulas, you have your z-test, and then it says if n is less than 30, use this one, okay? So this is for n is greater than or equal to 30. This is n is less than 30, do the t-test. Notice how it says the mean of the sample minus the population mean divided by the standard deviation over square root of n. It is the same formula here. They just used a different symbol for standard deviation, and they told you degrees of freedom was n minus 1. So it's still going to be the same thing. We're going to take the mean of the sample, which was 17.7, minus that mean of the population from step 1, which is 16.3. We're going to divide by the standard deviation, 1.8, over square root of the sample size, 10. When you divide that out, you get 2.46. So our test value is 2.46. Okay, so let's talk about where that is. Let me get this up real quick. We're going to put 2.46 on our chart. And, oops, I don't have that on there, so I'll write it out. 2.46 would fall over here. It is greater than 2.262. So let's talk about step 4. Now remember, step 4 always talks about the white area. Look at the white area. Is your green line in the white area? No. When it is empty, we reject the null. So on this one, we are going to reject the null hypothesis. Remember, if your test value had been in here, we would put do not reject. If it is not empty, you put do not reject. When it is empty, you put reject the null. Step 5, though, is about the claim. So this one's kind of interesting. So for step 5, the claim, you have to go back and see which one did they claim. Did they claim the null, which is the white area, or the alternative, which is shaded? They claim the white area. That means my evidence needs to be in the white area. So when I look at the white area, my evidence is the green line. The green line is not there. So I would say there is not enough evidence to support the claim. In other words, they say that they're equal, but there's really not enough evidence within alpha 0.05 to say that those two things are going to be equal. There's probably a difference in those. So for step 4, reject the null because the white area is empty. It doesn't have the green test value. And for step 5, they claim the white area. You look right here. The evidence, the green line is not there, so it's not enough evidence to support the claim.